Hi, my name is Randy Kochever, and I'm here with Dr. Sara Maxwell from Stanford University. Sara, how did you become a marine biologist?
I grew up in coastal Florida and southwest Florida along the Gulf Coast. And when I was young, after school, my dad and I would go out canoeing in the Everglades and in the mangroves. And so I've always just had a love of marine biology. And somewhere along the way, I decided I wanted to be a veterinarian. And I went really far along that path. And then the summer after my sophomore year of college, I decided just for fun I was going to go to the Duke Marine Lab in North Carolina and take a couple of classes just because I could. And there I met Larry Crowder. I took the marine conservation course there and a marine mammals class, and I fell in love with it, and I've never looked back, basically. So that's how I ended up doing what I do now. So.
Tell me about the classes that you took and how you became a marine biologist.
Yeah, being a scientist is interesting, and when you're in school, you take a lot of classes in science and a lot in math. And so I took, physics and chemistry and biology and calculus and all of those kind of courses. But one of the things that I think is really important being a scientist is writing and communication, and that's actually not something that you end up being trained for very much when you're in your university training as an undergraduate. So that's another thing that I think a lot of students don't realize, is that if you enjoy writing and you enjoy communication, it's a really important skill in science, in addition to the math and the scientific classes that you would normally take.
Mm-hmm. If you can, give me a summary of the work that you've been doing to understand human impacts on marine predators.
So I study a lot of big animals, turtles, seabirds, whales, that kind of thing. And the goal of my research is to see where they go. So to use satellite tracking to understand the way that they're using space and how they're interacting with humans, so that we can not only understand where animals are and where we want to protect animals, but also where humans are and where animals aren't. Because there are lots of things in the ocean that we as people rely on, things like fishing and shipping and those kind of things that we need as a society. So trying to figure out where in space and time those things are separated so that we can use the oceans more sustainably, including around marine predators.
What role do top predators play in marine ecosystems?
So predators are really important. They're really interesting, they're really fascinating, and they're really important. So they actually, there's been a lot of studies that show how predators actually keep ecosystems stable. So they eat a lot of things, they keep a lot of other populations in check, and those things that they eat are keeping other things in check. So they're at the top of that chain that's really keeping our ecosystems stable and important. And particularly for conservation, predators are really important. They're really interesting and fascinating, and so we as people tend to gravitate towards them. And then because they're so big and a lot of them are so mobile, when we focus conservation efforts around protecting predators and around protecting their habitats, we end up really being able to protect a lot of things under that umbrella of their habitat. So they're really important from an ecosystem perspective, but then their ecosystem perspective also really carries back into why we want to understand and protect them.
What kinds of human impacts affect top predators in marine ecosystems?
So there are a lot of human activities that impact marine predators, and they fall into a couple of different categories. There are ones that are really obvious, so what we call direct impacts. So if a ship, for example, a ship strikes a whale and the whale dies or is injured, that's a direct impact. Something like not often, but occasionally animals will be caught in fishing gear, like nets, or they'll be caught on hooks. And fishermen don't mean to catch them, but that happens sometimes because they're going after the bait just the way the species that they're trying to catch are going after bait. So that's another example of a direct impact called bycatch. But in addition, there are also other ways that predators are impacted. So things like pollution is a really big issue, and it might not necessarily, so there's direct kinds of pollution where if, let's say, a plastic bag is discarded and then an animal eats that, that's a more direct impact. But sometimes pollution will end up in an animal's prey, and as it eats something like, so for example, pollutants like mercury or other kinds of really strong chemicals, if they over time they start to eat, if those are eaten by the prey of predators, and then predators eat the prey, that begins to build up in their system. Over time they might have impacts like they're not able to grow as well, they're not able to reproduce like they normally do, and so populations tend to decline. So there are direct and indirect impacts that happen to predators.
How do scientists measure the effects that humans are having on predators in the ocean?
There's a lot of ways that we do that. There are really kind of these direct ways. So for example, lots of scientists, so if looking at the example of pollution, so some of these chemical pollutants that end up in an animal's system, scientists will, for example, take a sample, like a blubber sample. So they'll look at the fat of an animal to classify how much of that pollution exists in the animal, look at that over a whole bunch of animals, and then they have a sense of what that looks like. In my case, what we've done is we've looked at that from a spatial sense. So I'm always interested in where animals are going and how they're overlapping with different kinds of human impacts. And so what we do is, using satellite tracking, we look to see where animals are going. We try to understand what are the really important parts of their habitat, where are they spending a lot of time, either for feeding or for breeding, that kind of thing. And then we also look at where humans are going and where their activities are occurring, and we look at how those two things are overlapping in space and time, so that we have a sense of, here are the places that are really important to protect. These kind of impacts are really harming predators in this spot, so these are the kinds of things that we as a society need to do to make sure that they're protected in that area. For example, elephant seals are one species that a lot of researchers are studying, particularly at UC Santa Cruz, and they're looking particularly at these pollutants. So there's a number of students that are taking like blood and blubber and skin samples to understand how pollution is impacting these animals, and also looking to see how it's affecting their reproductive success when they come to the beach and they give birth to their pups. When they're nursing their pups, a lot of these pollutants get transferred to the pups, so they're looking at those kind of questions. And then they're also looking to see if they can correlate changes in whether or not these increase in pollutants are affecting the population as a whole, so actually resulting in less animals actually being born and making it into the population long term. There are also researchers that are looking at the impacts of climate change on elephant seals, so looking to see if we can see how where they're going is changing based on how the climate is changing and how the ocean is changing because of humans and carbon dioxide in the ocean. So there's a researcher at UC Santa Cruz named Chandra Getz who's actually looking to see, is there a difference in their pattern in terms of where they're going out to forage and when they're coming back, based on different patterns like El Niños that have increased over time because of climate change.
Can you explain how you measured human effects on these predators?
So I was part of a study, I led a study where we looked at the impact of humans on a number of different predators. And the way we did that was that first we used satellite tracks from a whole suite of different predators, seabirds, marine mammals, and sea turtles. And what we did was we first characterized where the animals were going. And we looked at not just generally where they've been, but we also wanted to have some sense of where is the really important habitat. So that was our first layer, so we started with that layer. Our second layer was a group of researchers at UC Santa Barbara created this really phenomenal data set of different kinds of human impacts in the ocean. And so they created this in a spatial layers of all of these different kinds of impacts, like climate change and pollution and fishing and shipping, that kind of thing. And so that was our next layer. So first we had animals and where they were spending a lot of time, then we had different human impacts. And so what we wanted to do was to be able to combine those two together. But when you think about these different kind of animals, the impact of a ship striking a whale is going to be really different than the impact of a ship striking a turtle. The chances of that happening for a whale are much higher than they are for a turtle. And so we wanted to be able to look at those things in a relative sense. So the next thing that we did was, for all of these layers that we had impact, we created a score that basically captured not only what's the likelihood of this happening, but also what's the impact likely to be on an animal, so that we had some sense of the relative impact of each of these things on individual animals. So then we were able to combine all those pieces together, and in space we were able to show here are the areas for different species where they're likely to be the most impacted, and specifically which human activities are going to have the most impact on the animals. So not only did we have this really big multi-species, multi-impact view, but then we could also look down into the layers to get to what managers really want to know. They want to know, okay, we've got this impact on an animal, what can we do? And so they can do things like, okay, we need to close this area off to fishing. We need to avoid oil and gas drilling here. We need to move shipping lanes so that they're not going to impact animals in other areas. So we wanted to have this big picture view and then also look at specific impacts and specific species.
Can you explain how you measured human effects on these predators?
So in order to understand human impacts on different predators, first we took satellite tracking layers, like the ones that you have available to you in Ocean Tracks. And what we did was we looked at not just where animals are going, but we wanted to understand what's the most important habitat, where are the places where animals are spending a lot of time. And we did this for a number of different species, for whales, for seabirds, for sea turtles. And so then so that was our first layer. We had these maps of where are animals spending a lot of time across different species. Then we wanted to look at what the human impacts are. In this case, we were talking about along the coast of the west coast of the U.S. And so you also have available these human impact layers. And so we use those same kind of layers to look at where in space and time are human activities occurring. Where are there things like pollution? Where are there things like oil and gas drilling and shipping and fishing? And so then we wanted to put these two layers together. So in order to do that, we looked at each of these individual layers and what's the relative impact of those on the individual species that we were looking at. So we created a single score for each of these impacts that relates how much is this activity going to harm an animal? How much is it going to harm a population? And then we put all of those pieces together, and we were able to look in space and time to say, these are the areas where we really need to protect for all species. And then if there were certain impacts that are really going to impact, really going to have an effect on certain species. So for example, shipping is a really big problem for whales. They get hit by these really large container vessels, and it can kill them when it happens. And so if managers want to know where are the areas where blue whales are spending a lot of time and where are the areas where there's a lot of shipping traffic, then they know this is the area where we really need to concentrate our effort. So we can look on the big scale and say, here are the areas where all of these animals are spending a lot of time, all of these human activities are occurring, these are the places that we need to protect, where we really need to focus effort. But then there are other little hot spots where managers can zoom in and say, these are the places where there are single impacts affecting single species, where we can work on this smaller scale.
What were the patterns that you found on human impacts along the California coastline?
So we saw a number of patterns when we looked at the impacts of predators along the California coast. Not surprisingly, a lot of the impacts occurred close to the coastlines. That makes perfect sense. First of all, there's a lot of people close to the coastline. We all love to be close to the shore. And in addition, a lot of the animals like it too, because those are the areas that tend to be really productive. We have all of this upwelling that occurs close to shore. There's a lot of rocks and nooks and crannies where different kinds of prey and animals can hide and where they can feed. And so those are attractive to animals as well. So that along the coastline is really where a lot of humans and animals come together, which is both a wonderful thing and it can be a tough thing when we're having an impact on each other. But interestingly, we also saw some other patterns. So some of the species we were looking at were pelagic seabirds. So they spend a lot of time further out from shore. And what was really interesting about our study is that we found that a lot of these seabirds were spending more time offshore. They weren't so close to the coast. But yet when we looked at the impact layers and we put all of that data together, we found that the higher impact areas were close to the shore. So what we learned from that is that if we really want to protect animals, we can't just look at where they are. We have to know also where they're being impacted by our activities if we're going to get the most bang for our buck in terms of protecting them.
Were there any surprises in your study?
So one of the things that was really surprising about our study is that we found that a lot of the highest impact areas were in the national marine sanctuaries. So that was really kind of a shock to us. We think of the national marine sanctuaries, we think of them as safe places for animals, but in reality it doesn't actually work all that well for marine predators. The sanctuaries are really important places and they do really important things for our coast, especially here in California. But the main reason that they were created was to protect against oil and gas drilling. When they were developed, most of them in the 70s and 80s, it was after a really big oil spill that occurred on the California coast, and so that was a major concern for people. So they came together and they created these sanctuaries to make sure that we did have sanctuaries free from this kind of harm and effect on our coastline. But things have changed and things have evolved since then, and so we have a lot more human activities and a lot more human impacts on our coast. And so one of the more surprising findings was that the sanctuaries were one of the higher impact areas, despite the fact that they are sanctuaries.
How do you hope that the findings of your research will ultimately be used?
So one of my goals in using satellite tracking for science and for conservation purposes is to understand where we can actually set areas aside to protect animals. I work here on the California coast, but I also do a lot of work in central West Africa, particularly in the country of Gabon. A lot of my work there revolves around tracking of whales, particularly humpback whales, as well as sea turtles, particularly olive ridley sea turtles and leatherback sea turtles. And so we've managed to amass a lot of information about the movements of these animals in Gabonese waters and up and down the coast of West Africa. We know that leatherback sea turtles cross the entire Atlantic Ocean and go as far as Brazil in the course of just a few months. And also humpback whales go from at the equator all the way down to Antarctica. We were really excited to find evidence of that migration. But in Gabon, the government there has been really interested in being able to better protect these kind of animals, and they are in the process of developing a marine protected area network. So a whole bunch of sites throughout their waters, with one of the intentions being to protect marine predators. So our information has been directly used for that process, and they're in the process of setting boundaries and creating these marine protected area networks based on the science and the satellite tracking that we've done. And it's really exciting. It should be announced in the next few months what the boundaries are. And the work that we've done and the satellite tracking has been a really critical part of that process.
What are the questions that you still have?
So most of my work to date has looked at animal movements. So even though they're really dynamic and they're really highly mobile, a lot of the questions that we've asked so far have been really looking at kind of snapshots in time. So understanding, where animals are going over the course of a season, over the course of a year. But really when we're looking at animal movements, they're really dynamic. I mean, they're moving really fast. They're moving over really long, large expanses of area. And the same thing is true of people. So when we do things like we create marine protected areas and we make their boundaries static, we have to always remember that animals, they're not staying in the same place, and often they're going in and outside of these marine protected area boundaries. And if we're trying to say, for example, reduce impacts from fishing and reduce bycatch, fishermen are really mobile too, so they're going to be moving around and potentially interacting with animals here, and then they'll move on, and then they might interact here, and they might move on and interact here. So one of the major projects that I'm working on now here at Stanford is this idea of dynamic management. So understanding the movement of animals and understanding the movement of fishermen and putting those together so that instead of having, for example, a static marine protected area, having one that's moving and shifting in time so that it's following the habitat of an animal and following where animals are likely to go so that we can better protect them while also leaving this space open to humans so that we can continue to use the ocean for the things that we depend on while at the same time still providing protection for these animals that are so important.
What advice would you give a student who's thinking about going into science?
So if I had any advice for students who were interested in being marine biologists or being scientists in general, I would say just continue to follow your passion. One of the best bit of advice that I ever received was from Larry Crowder here at Stanford, who said, you know, he figured he would just keep doing what he loved and it would work out. And I have to say, for me, it really did. I think if it's the thing you're interested in and the thing that you're passionate about, it might not be an easy road, but at the end of the day, if you're doing what you love, there's not much more you can ask for.
Thank you very much for your time.